Welcome to another day on the Journey Chez Chem. Today's warm-up is a little bit challenging, but I know you can do it. You had a few practice problems over the last day, so you will be able to predict products. So do the best you can, and we'll review the answers when you come back. It's a little bit challenging, but I know you can do it. The first thing we must do in these equations is write the compound we are starting with. Decomposing phosphoric acid, I need the formula for phosphoric acid. Whenever I have an oxyacid, I must find the charge of the nonmetal because it always decomposes to give me water and an acid anhydride. I know this acid anhydride has to be the same charge as the phosphorus I began with. If you recall, before when I was freaking out, it was because there was an acid anhydride. Well, now the acid anhydride is my product because I'm decomposing before I was synthesizing. Now this phosphorus is +5. Phosphate has an overall charge of -3. Oxygen is -2 times 4 is -8. The whole compound is -3, and therefore phosphorus is +5. It must be +5 here. And oxygen is -2. The common multiple is 10. Therefore, I need 2 phosphorus and 5 oxygens. Now, if I have 2 phosphorus here, then I must have a 2 coefficient there. Once I get the formulas, then I put in the coefficients. I have 6 hydrogens here, and therefore I need 3 waters to get those 6 hydrogens. The number of oxygens are balanced. There are 8 oxygens, and 3 + 5 is 8 oxygens, and therefore that equation is balanced. In this case, we have zinc that is reacting with nitric acid. You can see that it's very important that we understand our acid nomenclature in order to do these. We have a metal that is going to displace the positive position. Therefore, I get hydrogen gas and zinc nitrate. I still must balance my formulas, and zinc is a silly 6 that is always +2, and nitrate is -1, and that's why I need 2 of them. This is a single displacement, and the first one was a decomposition. Now we have 2 nitrates here, and therefore I need 2 nitrates, and I must put a coefficient of 2 in order to balance that equation. It's much easier to look at the whole polyatomic ion as a unit. Chlorine is one of my diatomic molecules. The diatomic molecules are iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. And I would write those at the top of my paper so that I would be reminded of them. Chlorine reacts with sodium bromide. In this case, the nonmetal will displace the nonmetal. And I will get bromine, which is also diatomic, and sodium chloride. I have 2 chlorines here. So once I get my correct formulas and everything is balanced, sodium is +1, bromine -1, sodium +1, chlorine -1, then I must balance the number of atoms using coefficients. The 2 chlorines here require that I put a 2 in front there. The 2 bromines here require that I put a 2 in front here, as well as the 2 sodium atoms that are required. That's how you do the first 3. The last one is magnesium sulfate plus water. Because you already have this one written down, I'm not going to write the sentence for you. Magnesium sulfate plus water. This is a compound plus a compound, so they must do the do-si-do. They do the do-si-do. Therefore, I get magnesium hydroxide and sulfuric acid. I also can recognize this as being a salt plus water to give me an acid plus a base. In this case, I can see that there are 2 hydrogens here and 2 hydrogens here. Therefore, I need 2 waters in order to balance the number of atoms, and everything else then is balanced. And that's how you do the warm-up. Now, in order to review predicting products, I would like to take a time to look at 5 different possible equations. I will give you these 5, and I would like you to do them to the best of your ability. Then we'll review them, and I'll discuss some specifics about them at that time. Then we'll review them, and I'll discuss some specifics about them. The first thing you might want to do when you try to do these problems is to write out your diatomic molecules. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. So that way we have bromine to begin with, and we see that it is one of my diatomic molecules. Plus calcium iodide. I must still balance my formulas. Calcium is +2 and iodine is -1. Therefore, I must have 2 iodines to get my compound to 0. My nonmetal is going to displace my nonmetals. And on the assessment, there are 2 separate general equations for a single displacement, whether we're replacing the nonmetal position or the metal position. So you must know both of them. And therefore, I get calcium, bromide, and iodine. And that's already balanced. Now, in this case, the subscripts did follow through, but that was just a coincidence, and normally we cannot make that assumption that that will happen. You must still make sure that you balance the charges of your compounds, and the calcium is +2 and bromine is -1. The next one is a decomposition of a metallic chlorate. Sodium is a metal, and we have chlorate. When we start with one compound, we have a decomposition. And we are just going to have to memorize those different types of decompositions. And I see that oxygen is in this compound. We're going to drive off the oxygen and get that common molecule of oxygen. And then what's left is the metal chloride. Once I write my formulas, then I can look for coefficients. I have 3 oxygens here and 2 oxygens here. The common multiple is 6. Therefore, I need 3 oxygens and 2 of the sodium chlorates. When I get 2 sodiums, then I must have 2 sodiums here as well. And then it's balanced. The next one is aluminum plus hydrochloric acid. This is a single displacement where the positive position is being displaced. We get aluminum chloride and hydrogen gas. And as I've said many times, we must still balance our formulas. Aluminum is one of my silly 6s, and so it is +3. Chlorine is -1, and therefore it is AlCl3. Now, I'm going to put a 2 in front of this aluminum to get 6 chlorines so that I get 6 here. And then I must have 3 hydrogens, and I had 2 aluminum, so I need 2 aluminums. That one was a bit more challenging, but I know you can do it. Magnesium hydroxide is a base. Metal hydroxide is a base. Now, when we decompose this base, we're going to get water and a base anhydride. And the metal in the hydride, anhydride, is magnesium. And oxygen is -2. So it's just MgO. That reminds me of a song I know, MgO. Well, I don't know. Maybe you don't think of it that way. But in any case, this is a base, and I always drive off the water and get the acid anhydride. Excuse me, the base anhydride. I get a base, I take out the water, and I get a base anhydride. Very important to recognize. The final one is we have an oxyacid. HClO4. Now, you remember I was freaking out about those acid anhydrides. Well, when I have an oxyacid, I'm always going to get an acid anhydride. I drive off the water, and I'm going to get some form of this nonmetal chlorine and oxygen. In order to determine which formula I get, I must determine the charge of this chlorine. Now, perchlorate has a -1 charge. Oxygen is -2. There are 4 of them. That gives me a -8. The polyatomic ion is -1, and therefore my chlorine is +7. If it is +7 here, it must be +7 here. Oxygen is -2. The common multiple is 14, and therefore I need 2 chlorines to get +14 and 7 oxygens to get -14. And +14 and -14 is 0, and compounds must be 0. Now, I hope that this was a little bit of review for you and that you feel better about it now. And you have worksheet tonight to do a few of these practice problems, and your facilitator will go over the ones that you had before, and you should be getting more and more skill at doing this. In a couple of days, we will have a quiz where you will have 5 equations that you do that are just sentences, and you convert them to symbols and balance the number of atoms, and you will have 5 where you only put in the coefficients. And tomorrow's warm-up will show you an example of that type. So we had some fun today, and I hope you're feeling better, and we'll see you tomorrow.